Next, we'll hear about orchestrating robot framework test containers and remote libraries in Kubernetes. Please welcome onto the stage Joonas, Köppä, and Riku Halonen.
Can you hear me? Yeah, so first of all, I was surprised to see how many nationalities we had here. So I wish to welcome you all here to see our presentation. Benvenuto, benvindo, huaning, and welcome. And let's get this show started. So our topic is, like the announcer said, orchestrating robot framework test containers and remote libraries in Kubernetes. So let's have a quick show of hands. How many of you are familiar with Kubernetes? Okay, that's good. That's good. Well, we saw some of it in the last presentation, but anyway. And how many of you have run some robot framework tests within containers? Oh, almost everybody. So that's great. That's great. So let's start the show, and I'll let Riku first tell you a little bit about our company.
Yeah, maybe some introductions first.
Yeah, well, I can start. So my name is Joonas Köppä, and I'm working as a senior software engineer at OpenText. And this presentation is actually based on my bachelor's thesis, which included the first iteration of creating this Kubernetes-based way of running robot framework tests.
Yeah, good afternoon on my behalf as well. I'm Riku. I work as an engineering manager at OpenText development department. What we are showing here today is built in my team. Joonas is part of that team. We're also doing other things, building different test automation tools, solutions, sharing those within our company, organization. But we are also working on the DevOps side, automating DevOps processes and DevOps pipelines. This work initiated already in a company called Liaison Technologies, but about a year ago we were acquired by OpenText, so now we're continuing work within OpenText. So that's why the logo in the top right corner. You might see the Liaison name in the demo as well, so just FYI. Few words about OpenText, because I know that we may not be that familiar, at least in Finland, but we are actually a global corporation. Our headquarters is in Canada, Waterloo. In Finland, we are located here in Helsinki and in Tampere, and actually both of us are based in Tampere. And in fact, in Tampere, we have the biggest R&D site in Scandinavia or Northern Europe within OpenText. Here you see some of our solutions or products corporation is being implementing. We have content management solutions, security. We have some VPN technologies built, AI, analytics. But we are mostly working on the business network side, and there within the business integrations and the cloud products. Then to describe the context a bit and what's the product we are working on, so that you get kind of the idea for this presentation. So we are working on a cloud-based platform focused on integrating cloud and on-premise applications. So our customers are companies, corporations. Our customers have trading partners, and They usually have a challenge or a problem that they need to transfer documents, data to their trading partners, and that's where we come to help. So we do the integration between our customers and their trading partners. And that's the business-to-business integration. The platform roughly contains 3 different layers. So first is this integration layer, where we transform and transmit data between application endpoints. So we might have a SaaS application sending data to a system that is located on-premise. It might be a legacy system. And our cloud platform handles the transmit, maybe transformation to the other endpoint. Then the second part is the data management layer. So we might collect some data from the integration points, for example, and store that data maybe in a database, and then we can provide APIs to our customers, and they can build some of their own tooling or UIs on top of that. Then we have also some visibility, web-based applications. For example, we have a product called Lens. You can check that from OpenText site, but Lens is mainly a tool for our customers so that they can monitor the integration flows. This is a microservice-based architecture. We have roughly 60 microservices running in containers. We're running that on Kubernetes. This is deployed in an on-premise cloud, so it's a private cloud. Currently, we have roughly 40 customers globally in production, and each of the customers might have several integration points built onto our platform. And now Joonas is going to dig into technical details and tell more about how we have built our CI/CD pipeline and using Kubernetes and Docker on top of that.
Yeah, so let's dig into the technicals. So we are using Git repositories, multiple different types. For different types of repositories, we have our services and tooling in the code repositories, and then we have environment-specific configurations in another repository. And whenever there are some pull requests or merge requests, they get automatically built and unit tested, and we built a Docker image out of that repository and just see that everything works. The build goes fine, that's fine. And then there's a review. We have to review all those pull requests before they get pushed by Jenkins to the actual pipeline. Now, Jenkins will start the automated deployment by deploying the service or tool, like the remote library, for example, into our dev namespace. And like yesterday in the Chili presentation, we heard of those mad coders and brittle dragons and whatnot. So dev is the namespace where those people thrive. So we don't actually do acceptance testing there that often. We start from the QA stage, actually. And in this case, in the demo, I will show at the end, we do the testing in the dev namespace. And you can see those lines between those different namespaces. It's because every time we run those tests, they will report back to Jenkins, and if tests fail, the whole pipeline is failed, all the way to production. So here's a quick overview of our tool stack. We do the checkout. Jenkins checks out the code from either GitHub or GitLab, depending on what kind of repositories we want to use. We build, this is for the actual testing. So our test containers, they are a Docker image where we have Python installed and robot framework. We try to keep them as lightweight as possible, so they are quick to spin up and lightweight to use in general. And then the tests get deployed to Kubernetes, where they are run and report back to Jenkins. Now, since we're running Kubernetes, we can't access those log files and stuff so easily. So what we have done is, first of all, we monitor the test runs with Elasticsearch, Logstash, Kibana, etc. And we are using New Relic to see the pod statuses to know if something goes wrong, for example. We can see the reasons in New Relic sometimes. And on the reporting side, we use Slack and Microsoft Teams integration to get immediate feedback about whether the test succeeded or not. Then we have the QA reporter, which is our own proprietary tool for viewing those results, because we also want to view unit tests, performance tests, and acceptance tests in one location. So we use this, our own tool, QA reporter. Now the test containers we run in Kubernetes are run within a Kubernetes pod. And it's a Docker image, and here you can see the contents of said image. We have our custom test runner, which is built on top of the great Pabot. And we have the test data inside the Docker image, robot framework and Python, of course. And then the easy-to-use Python test libraries, not the remote libraries, but only the test libraries that are normally used. And the thing is, we run this in multiple different namespaces, so we have to have some way to tell the test runs, like what kind of endpoints to use. Maybe the credentials are different in different namespaces. So we use Kubernetes config maps and secrets to inject those values into our test pods. Our images are version controlled, so it's easy to say, like, yeah, we run the test version 1.0.3, for example, and the pods are run into completion, so we expect a pod to start, do the testing, and finish. If it doesn't finish, something has gone wrong. Here's an example of our test data. So, like I said, we have one test case which we want to run in multiple different environments. So we have these variables like remote library URL and test environment, which are injected into our test code. We also use this variables common file for variables that are common to all of those environments. And yeah, this test model is good since we can run it in multiple different environments. We have multiple clusters geographically distributed, so we have some in the EU and some in the US, and we need to have different remote libraries in those, so that's why we also have to inject the remote library URL. Here's the life cycle of our test containers. So first, Jenkins it deploys the test image to be run alongside the service. So we have a new version of some service we want to test. Now Jenkins deploys the test container next to that service in the same namespace. After deploying the test container, Jenkins will just wait to hear back if the tests passed or failed. What comes next is the test container handles all the execution of the tests. And we can set up some specific parameters, like tags, of course. So we can tell if the microservice is called service X, then we can tell the test container to only run tests that are tagged with service X. And also, since we utilize Pabot, we can tell the test container how many parallel processes we want. Because some test cases might include a lot of waiting, like if you move files in the SFTP or something. So we want to run a lot of those in parallel and minimize the time of waiting. Once the tests have been run to completion, the test runner, the custom test runner, will publish the test reports from the container to our QA reporter, and it will also report to Slack and Teams as described before. The final thing the test container does, it notifies back to Jenkins saying, okay, tests passed, you may continue the pipeline, or tests failed, please abort the pipeline. Here's a quick overview of the remote test library we use. So we had a lot of previous Java libraries to use for our testing, so we wanted to go with this way. And also, as we heard in the previous presentation, running them in Kubernetes, you might not have some database access or some other reasons why you can't directly connect to those services. So this remote library seemed like the perfect choice for that one, and it's written in Java. We deploy it to each cluster. It's also version controlled, so whenever we create a new version of the remote library, it has its own Jenkins pipeline that pushes it to all the relevant clusters we have. We can also run the tests from developers' local computers. They just have to add the URL into their test code or inject it as a variable. And they can also run tests against services in Kubernetes directly from their computer. I think this image illustrates pretty well what the workflow is inside of the cluster. So at the bottom, you see the Jenkins agent, and it will deploy the job, which will have one pod with one test container inside, which will then call keywords from the remote library, which will then execute actions against those platform services under test. And we do it in multiple namespaces and multiple clusters. And we always deploy the same tests, but it depends on those config maps and secrets you see in the pictures, whether, like, which endpoints the test will use, for example. And now, at the end, we want to show a quick demo. So I have a new service version, which was merged into the master branch. And as the pipeline goes on, Jenkins will first start the pipeline. It will create a new Docker image of the service and publish it to our own Docker registry. Then it will deploy the service into our dev namespace. The next thing, it will start that robot framework test job alongside the service to test it. Tests will run into completion and report back to QA reporter and also notify Jenkins about the test completion. And the pipeline will be successfully finished. So let's get on with the demo. One moment. Normally we trigger this pipeline automatically, but now I do it manually just for the sake of this demo. At least I literally tested it like every hour between this, like every hour.
Now it fails.
There's no way. There's a little bit of time still, so yeah, it seems to have logged out for some reason.
Oh yeah.
Okay, that's good. Okay, so down here at the bottom you see our Kubernetes cluster, and you see we have currently selected the dev namespace. And currently all we have is one ingress for. I used it for external testing because the ingress lets me connect to those services from outside of the cluster. And then one service, which is just an easy name to identify those pods. So these are not related to the test, so don't worry about those. But now, as the pipeline starts running, you will see one deployment being deployed into our Kubernetes. You will see how the test container is deployed alongside it. Okay, so now the pipeline is ready to start. Yeah, so it will then, after deploying the service, it will deploy the test container, and then we can show you how we actually see the test results. Now Jenkins is checking out the service source code for building from GitHub, actually. Now it's building the service. I don't currently have any unit tests since this is just a simple demo, but this is where we would do the unit testing, and also the next step is building the Docker image. We always want to do both of these steps before deploying to make sure that the code works as expected. Okay, a Docker image is getting currently published to our Docker registry. And the next step will be to actually deploy it. Now Jenkins is telling Kubernetes, start this service we just created, which is version 1.0.3 of this Robocon demo service. And after a moment, we will see the deployment actually appear here in our Kubernetes dashboard. It's not there yet, but as you can see, it's progressing. Almost done. Here, oh,
it's not that accurate. I mean, the time.
Yeah, it's pretty accurate since like I said, I ran it like 1 million times to be sure, sure that it works. So this is, yeah, a little bit more about Kubernetes. So in Kubernetes, you have different types of deployments. You can have those deployments that run forever, which are called deployments, and our services are that type. So we want to run, let's say, user management service is always up. And then these test containers or whatever, those are just like quick tasks. You could call them tasks. They are called jobs, actually. But the point is they are just executed, and then they are deleted. They won't take any resources after that. Okay, now it's been deployed. We refresh the dashboard, and you will see, okay, Robocon demo service, age 20 seconds, and which image it's using. And it has one pod, so you see this pod, it will always run. It's designed to be up all the time. And now you see Jenkins has begun running the robot tests, so it deploys the test image, the test container in the same namespace, the dev namespace, and then that container will communicate with the remote library, which will then actually perform those actions against our service. Yeah, I think this is one of those slow runs. You see, normally it took like 23 seconds, but if it's been offline for a long time, then this is what happens. But I can show you like when.
Yeah, you can show maybe the report from some of the old.
Yeah, I will also show. I have some old reports. So yeah, it's not running yet the test. Anyway, once the test has been run, we can see in our QA reporter that there's a Robocon demo tests, and it's been run today, version 1.0.3, so we gather all our test results here. We can go to the reports and see 3 test cases were run, 3 passed, and next section will tell us what tags we use. So we use the Robocon tag to tell our test container we only want to run these specific tests. You can see the build ID, you can see what branch, you can use these links to go read some more about it if you want. And then which service was tested, so Robocon demo service version 1.0.3, and all the actual test cases which were run. And in case we have failures, we can actually see the log files and everything here, so we also keep those. And also we could see the error messages here. So this is a really good way of maintaining all our reports. Okay, now the test job has been completed, so I can also show that on Kubernetes. So the job is here. It's been run 16 seconds ago. It created a pod, which has been completed successfully. So this is the way we are doing it now. It's very quick. It's very maintainable, since these images work the same wherever we put them. You can run them locally, and they work exactly the same. And then okay, well, questions?
Oh, thanks.
Thank you.
Can you hear me?
Yep.
Yep.
Are you building only a single Docker image that goes through all the stages, or do you build separately?
We build one, when we create new tests, we build one test image, and then that image will be, first we deploy the service to dev, and then QA. We will always run that same test image since we collect all the related tests into one image, and we can just run that whenever we want to test. If new tests are created, they are added to a new image, which is also version controlled, and we can run that in any namespace.
But the image containing the actual system under test?
No, the image only contains robot framework, Python, and the test files. And the system under test is a microservice that is deployed in the same namespace. So they are very lightweight containers.
Okay, thanks.
Oh, nice guy.
About those remote library you mentioned, there was only 2 pods running, so where is the remote library?
That's a good question, actually. I almost wanted to show you before even questions, but I don't want to show you everything we are running, but we have here this CI namespace, and the remote library is in the CI namespace, but it has access to communicate with services in any namespace.
Okay, thanks.
More questions? Anyone there?
Hi. Is your QA report available?
No, actually, it's our proprietary
We have
one.
been thinking about open sourcing it.
It's really good, I have to say. So.
Yeah, we'll take it.
Yeah, there's well, it's off topic, but we store the raw robot framework JUnit file into or where we send it to a backend service that converts that into a JSON object, and that will be put into our AngularDB, and then we have this front-end application here. This is a bit older version. We have a new version coming with new OpenText styles and so on. But I think before open sourcing it, we would need to polish it a bit, remove all the company-related things and so on.
Can you show the report a little bit more? What else it can do than just show? Does it show trends, or does it show all the test results, or does it show only one run?
I'm not sure if I can. Here, yeah, because there's might be a bit confidential information here, so I'm a bit scared what to show. But yeah, so like you don't see if any of the tests would have failed. We are actually uploading the HTML report, output it from the robot framework into a Google Cloud Storage, and we would be getting the link here. Now that everything passed, we don't really care about those logs, so we don't have that link in here. But yeah.
Hi. Yeah, I have a question. If you wanted to see console logs, how do you?
That's in the monitoring. So we have a Kibana and Logstats and whatnot. So everything we run in Kubernetes will automatically get the logs to be viewed in Kibana.
Oh, okay. Well, what's wrong with the Kubernetes dashboard itself? Because it should have a log.
It has a log, but you don't want to go there to look what went wrong if you can just search on the Kibana.
We don't keep the logs there that long, so that's why we have the elk stack.
Okay.
So like everything we log into standard out of the container will be shown in Kibana.
Got it.
Yeah. Okay. Thank you, Joonas
Thank you.
and Riku.
Thank you for having us.